This lesson is on solving systems of nonlinear equations. So if you will recall from 9th grade or maybe middle school, you solved systems of linear equations, where you graphed two equations that were lines and you found where those two lines intersect. It's the same concept when we look at nonlinear systems, except instead of having two lines, we're going to have a line and a nonlinear graph such as a quadratic. So if you look at number 1, the first equation is y equals negative x plus 1. And that equation is a line. But the second equation, y equals x squared plus x minus 2, is a quadratic. So we're going to start by graphing the first equation. This first one here I'm going to do in purple. We're going to start at 1, which is the y-intercept, so it moves the graph up 1 unit. And then our slope is our negative in front of the x. So our slope is a negative 1, meaning we're going to go down 1 and to the right 1, down 1 to the right 1. Now we are going to make sure we have quite a few points here because we don't know where this parabola is going to intersect this particular line. So the more points, the better chances we are going to be able to see that intersection point. And you do want to try to use a ruler. Okay, I don't have a ruler, so I'm going to do my line as straight as possible. But if you have a ruler or a straight edge, you really would like to use this on this type of problem, because if not, it can be hard to see where they intersect. All right, my second equation is a standard form quadratic. So if you'll recall, to graph a standard form quadratic, the first thing we have to find is our vertex. So in order to find our vertex, we're going to find our axis of symmetry. So the formula for axis of symmetry is negative b over 2a. So in this case, our b is what's in front of our x. So that's an understood 1, negative 1. And our a is what's in front of our x squared, which is also a 1. So that means our axis of symmetry is at negative 1/2. So now that we have our axis of symmetry, we can find the rest of our vertex by plugging that in. So our vertex is at negative 0.5 or negative 1/2. We need to find the y value by plugging this negative 0.5 into our equation. So y equals negative 0.5 squared plus negative 0.5 minus 2. And when you plug that into the equation, you should get negative 2.25. Okay, so do double check and make sure it works in the calculator, but it should. And now that we have our vertex, so being at negative 0.5, negative, it's right about there. The next thing we need to do is we need to find some more points. So the reason we find the vertex first is so we know where to look for points. In this case, we want to look on either side of the vertex. So our vertex is going to go in the middle, and then I'm going to pick some points that are a little bit bigger and a little bit smaller. Now I may have to add more points to my table, but I'm going to start here and see if this is going to be enough. So at this point, you can either start plugging each one of these into the equation. So you can plug negative 3 in for x in this equation here. The y equals x squared plus x minus 2, you can do it for every one of them. Or you can use your calculator, type in the equation, and get the table, which is a little more efficient. So that's what I've done. So when I plug negative 3 into that equation, I get 4. And when I plug negative 2 in, I get 0. When I plug in 1, I get negative 2. Then I get the same thing for 0. For 1, I got 0, and for 2, I get 4. So when I graph this, negative 3, 4, 1, 2, 3, 4 is right there. And notice those points intersect. Negative 2, 0 is right about there. And negative 1, negative 2 is really close to the vertex. Same thing with 0, negative 2. 1, 0, again, we can see they've overlapped. And 2, 4. So we are able to see some intersection points here. So I'm going to draw my quadratic. And these points right here, where they intersected, would be our solutions. Okay, and notice we're not going to get any more intersection points because our line's not going to change directions and our quadratic's not going to change directions. So there's only 2 intersection points for this particular function. So our answers would be these points. So that first point is negative 3, positive 4. And that second point is going to be 1, 0. So these are the answers to this system, and there are 2 of them. Okay, so let's look at number 2. Again, we have a line and a quadratic. So I'm going to start by graphing my line. It starts by moving the graph down to negative 3. That's our y-intercept. And then in this case, our slope is 2, which means you're going to go up 2 and over 1. Up 2 and over 1, up 2 and over 1. And you're going to do the same thing going down. Again, being very attentive to the fact that we want a straight line. If it's not very straight, it's going to be hard for us to see where these lines intersect, these graphs. So that one's okay. Again, yours should be a little straighter than mine. And then I'm going to graph my quadratic. So this is technically in standard form, however, it's also in our transformations. What that means is, if you realize that this is going to move, this -2 moves the graph, the parent, down 2 units, you can just use that. So it starts at -2 right here, and again, this is why you want to be really careful to draw your line straight, because if it was crooked, that point might look like it's on the graph. And then we're going to go up 1 over 1, up 3 over 1, up 5 over 1. And same thing on the other side. Being very careful when we draw our quadratic not to intersect too many times, because there was only one point down here at the bottom where they intersected, and it was right here. Okay. Now, we do need to be careful not to assume that's the only intersection point. This graph might intersect later on. However, if this line continues chugging away over here, and this quadratic continues shooting up, they're not going to intersect again. They're going to keep getting further apart because the line's not moving quick enough, and the quadratic's moving just a little too quick. Now, on the other side, we can be sure they're not going to intersect because this one's going up, and this one's coming down. So they're not going to intersect again. There's only one intersection point for this particular function, this system of equations, sorry. So that point is +1, -1. And I will tell you, you might want to double check your answer because it's very easy, especially with something like 1, -1, to transpose your numbers and tell me -1, +1. So what I mean by checking your answer, you can actually plug this 1, -1 back into both the equations. So if we check this, we would say, does -1 equal 2 times 1 minus 3? Well, -1 does equal 2 minus 3, so that's a check. But we wouldn't want to stop there. We'd also want to check the y equals x squared minus 2. So is -1 equal to 1 squared minus 2? Well, -1 does equal 1 minus 2. So we can know for a fact that this solution does work by plugging it back into the functions we started with. Okay, so at this point I would like for you to try number 3. So go ahead and pause the video, and when you're ready, turn it back on. Okay, now I'm going to show you the answer. So notice we don't see an intersection point on these two graphs. The quadratic is forever rising, so it's going to continue moving up. And while this line is moving up to the right here, it's not moving quick enough to catch up with this quadratic, which means these two particular graphs are not going to intersect. So if there is no intersection, and that's the whole point of solving a system, where do these two functions meet up? That means this particular system doesn't have an answer. So what we would write here is we'd say no solution. Okay, and notice we have 3 different types of systems here and had 3 different possible answers. Our first system had 2 intersection points, 2 answers. Our second system only had 1 intersection point, and our last graph didn't have any intersections. Okay, this is typical of quadratics. You're not going to get an intersection of more than 2 points with a line and a quadratic. They just don't have enough turns and curves in them. But you could get 1 and you could get none. Okay, so being very attentive that there's 3 possibilities.